Alright guys, welcome to using prime factorization to simplify square roots. So I'll remind you that a prime number is a number that is only divisible by 1 and itself. So it says to simplify square roots in which the radicand, right, our radicand, or the number or expression, so that's our radicand that is in the square root. So the number or expression in the square root symbol, that's called our radicand, in which it's not a perfect square. We're going to identify any factors of the radicand that are perfect squares, and then write the perfect square factors outside of the square root symbol. All right, so this is their method 1. Right. So I'm going to call this method 1. All right, method 1 is, they said to write the radicand as a product of numbers, one of which is a perfect square if possible. If not, continue to factor. And so what they've done is they've rewritten 180 as 2 times 90. And then they recognized that there were no perfect squares yet, so they continued to factor and recognized that 90 was 2 times 45. At this point, they do have a perfect square. The perfect square would be right here, our 2's. They recognize that this still factors further, that 90 is 45 is 5 times 9. And they went ahead and rewrote the 2 squared as 2 squared and the 9 as 3 squared. And then they said that you can determine the square root of each perfect square by writing it outside of the radical. So the square root of 2 squared is 2, and the square root of 3 squared is 3, and the square root of 5 is an irrational number, and this is their final answer. Now, something that we haven't, or that I encourage you to do, and some of your calculators do simplify radicals for you, but you can always look on your calculator and do second function, right, square root 180, and see what you get. And then do 6 times second function, square root of 5, and you should get the same value. And if you don't, then you've done something wrong. I'm going to do another method, my preferred method, method 2. It's similar to their method, but method 2, square root 180. So what I'm going to do is, I know that 9 goes into 18, so I know that 9 goes into 180. So I'm going to write this as the square root of 9 times 20. And then I know that the square root of 9 is a perfect square. The square root of 20, there are 2 numbers that multiply to 20, one of which is a perfect square, 4, and times 5. And then I'll evaluate each square root. The square root of 9 is 3. The square root of 4 is 2. The square root of 5 is irrational. And then I multiply my outside digits, and that would be 6 root 5. And I'm going to show a third method, which is really the same method again, but I'm going to show you a method that it's called upside down division, and a lot of students prefer it. And so what we do is we take 180 and we pull out a number that goes into 180, but these have to be only prime numbers. So I know, for example, 2 goes into 180 and 2 is prime. And so that would leave me with 90. 2 times 90 is 180. 2 times 90 is 180. All right, I'm going to take out another 2 because 2 still goes into 90, and that gives me 45. Now, 2 times 45 is 90, times 2 is 180. I know 5 goes into this, so I'll take out a 5, and that gives me 9. 5 times 9 is 45. 45 times 2 is 90. 90 times 2 is 180. And then finally, I know that 3 goes into 9. 3 times. And once you get to all prime numbers, you can stop. Anything that doubles up, so I have a pair here. So pairs come out. Right? Pairs, like if you have a partner, you go out on a date. So pairs come out and singles stay in. So I'm going to pull out the 2, and I'm going to pull out this pair of 3s, and the single stays under the radical, which gives me 6 root 5. So I've given you 3 different methods, and you get to use whichever one you prefer. I generally use this method. All right, let's flip to the next page. So we have some guided practice. So step 1, fill in the missing step or explanation for this simplifying the square root of 392. So let's fill in our missing steps. So step 1, let's see what they did to get from this 392 to this, right? 2 times 196. And so this is right the radicand as a product of numbers. All right, step 2. So they recognize that, okay, wait a minute, 2 is not a perfect square. So this isn't quite step 2 yet. Step 2 is going to be right here. They said there's no perfect square yet, but I see that there's still a 2 that's a factor of this. So rather than writing it as 2 times 196, they rewrote it as 4 times 98, because 4 times 98 is still 392. And so they saw, oh, well, that gives me a perfect square right here. And then for 98, they looked to see if there was a perfect square. So this is where they're try to find perfect squares, right? And that's what they're trying to do. So they noticed that 98 could be rewritten as 2 times 49. So now they have 2 perfect squares. Okay, so it says factor until the radicand is written as the product of prime factors. So prime factors, that means 2 times 2 times 2 times 7 times 7. So this was my 4, and this was my 49, and my 2 stayed. And then I can rewrite this 2 as 2 squared, right? These 2 2's. I can rewrite these 2 7's as 7 squared. And so this would be rewrite or multiply the prime factors to create perfect squares. And then it says determine the square root of each perfect square and write the roots outside of the radical. And so the square root of 2 squared, or the square root of 4, is 2. And the square root of 7 squared is 7. And it says to write them outside of the radical, I'm going to say with multiplication between. And then under the radical, we would still have a square root 2. And then step 5 would be that all perfect squares should be multiplied when moved outside the square root. So multiply outside, and sometimes even inside as well, the radical. All right, so we're going to fill in these missing steps to simplify the square root of 675. And so they said the square root of 675 is 5 times something. Well, I don't know. I don't want to do it in my head. So 675 divided by 5 is 135. 135. Well, so then what I notice is that 5 still goes into 135. And so they've taken another 5 out. So I'm going to divide 135 by 5. Which gives me 27. And then I noticed that 27 is 9 times 3. So I would rewrite this as 3 times 3 times 3. Now I can rewrite the 5 times 5 as 5 squared, the 3 times 3 as 3 squared, and then this 3 separately under the radical. Then I can evaluate each perfect square. The square root of 5 squared is 5, the square root of 3 squared is 3, and the square root of 3 is irrational. And then finally I would multiply these two values together and leave the 3 under the radical. And so you have some independent practice. I am going to do this problem the way that I would normally do this problem. So I have the square root of 675, just so that you can see my method. Now I know that 25 goes into 75, so I know that 25 goes into 675. So 675 divided by 25 is 27. So I would rewrite this as 25 times 27 under the radicals. And then I know 27 is 9 to the third. I'm sorry, is 9 times 3, not 9 to the third. And so now I see my two perfect squares. The square root of 25 is 5, the square root of 9 is 3, and the square root of 3 is irrational. And that would still give me 15 square root 3. And then I'm going to use that other method, the upside down division method, which is really the prime factor method, but this works well for a lot of students visually. So 675, I look for a prime number that goes into it. So remember, these have to be prime. So a prime number would be like 5. 5 goes into this. So 5 goes into 675 135 times. You can multiply these back and you'll get 675. I see that 5 goes into this value. 5 goes into 135 27 times. And then I know 3 goes into 27. So 3 goes into 27 9 times. And we're still not prime factored because 9 can factor further. This 3 goes into 9 3 times. So if I multiply here, I get 9, then multiply again, I get 27, and then 135, and then 675. And again, we're going to take the pairs out, right? Couples go out. So a 5 comes out, and a 3 comes out, and singles stay home. And that would give me 15 square root 3. So you can use any of the methods that you prefer. Here's your homework for tonight. If you have any questions, please email me, and have a good evening.